Singapore Mathematical Olympiad SMO 2021 senior section round 1. We want to consider the answers. Maybe we use some ideas, some theorems. If you had any questions, any problems, as I said in my other videos, feel free to send message to my WhatsApp number here and also in the description. Also for having next videos, because I want to release all the solutions of the other years, other sections, other rounds. Subscribe my YouTube channel to have next videos. Okay, so here let's start from problem number 1. Let P be a real number such that the equation x squared minus 10x equals P has no real solution of the following. Which of the following is true? So here when a quadratic formula doesn't have any solution, it means the discriminant is less than 0. So it is the discriminant here is what? Here is 100 minus 4ac, which is plus 4p, should be less than or equals less than 0 strictly because it has no real solution. So you say, okay, p is less than negative 100 over 4, which is less than negative 25. So the answer is D. Singapore Mathematical Olympiad SMO 2021 senior section first round problem number 2. Which of the following is the largest? You can imagine unit circle, or if for example you've not solved many problems with unit, for example in trigonometry and using unit circle, you can draw it. For if you want to know for 45, let me show you. It is for sine, it is for cos, this line horizontal line, and this line is for tangent. And if I show, for example, for 45, tangent is 1. For 45, the tangent is 1. It is for tangent, it is for sine, it is for cos. So the first one, tangent 50. Tangent 45 is 1, so tangent 50 will be greater than 1. So here, if you consider, let me write with blue, tangent sine 50, here cos 50 on. And if you want to consider sine 50 and cos 50, in this place, sine and cos are equal in 45. For 50, sine is greater than cos. So sine 50 is greater than cos 50. And okay, so if you consider these two cases, we can cancel with A and B. Because of A, we've reached contradiction. Sine 50, cos 50. Here, sine 50 will be cancelled. Tangent 50 is greater than 1. So here you say, okay, if you consider cos 50 is at most 1. Again, by using part A, you can reject it for this one. Sine 50, tangent 50, sine 50. Sine 50 is a number between 0 and 1. If you consider a square, it will be less than the first case. So you reject it because of again part A. For this part, sine squared 50 plus cos squared 50, it is equal to 1. But tangent 50 is greater than 1 plus something positive. So by part A, again, you will reject this. So the answer is this choice, A. Singapore Mathematical Olympiad SMO 2021 senior section first round. Problem number 3. Find the value of this term. Let me tell you at first the definition. With the definition, you can solve this problem. Log x in base b is a. Log x in base b is the number that if we raise b to the power of that, you will reach x. So, for example, log 2021 base 2020, if we consider it is, for example, a, it is the number if you raise 20 to the 21 to the power of this, we will reach 2020. So here, because we have 2021, you raise it to this power, it will be what? 2020. If you raise exactly similarly by this definition, it's a number that if you raise, look, let me tell you, it's the number that if you raise b to the power of that, you will reach x. It is the number, this one, that if you raise 2020 to the power of that, you will reach 2019. It is 2020. 2019. It is the number if you raise 2019 to the power of that, you will reach 2018. So the answer equals 2018A. Singapore Mathematical Olympiad SMO 2021 senior section first round problem number 4. Suppose sine theta equals n minus 3 over n plus 5 and cos theta equals 4 minus 2 n over n plus 5 for some integer n. Find the maximum value of 160 times tangent squared theta. Okay, so the first thing we know is sine squared theta plus cos squared theta equals 1. So we can say n minus 3 over n plus 5 squared plus 4 minus 2n over n plus 5 squared equals 1. If we multiply both sides by n minus n plus 5 squared, it will be n minus 3 squared plus 4 minus 2n squared equals n plus 5 squared. Now, if we expand, we have quadratic formula then. N squared minus 6n plus 9 plus 16 plus 4n squared minus 16n equals n squared plus 10n plus 25. Now, n squared will be cancelled. We have 4n squared. And 9 plus 16 and 25 will be cancelled. The coefficient of n will be negative 6, negative 16, negative 10. Let's check. Yes, so it equals 0. And we can say, okay, 4n squared, 6, 16, 22, 32, minus 32n equals 0. And if we divide by 4, then we have n squared minus 8n equals 0. So n times n minus 8 equals 0. So n is 0 or n is 8. So for the first case, n is 0. Sine theta is what? Is negative 3 over 5. Cos theta is what? 4 over n is 0, 4 over 5. So tangent theta is what? Is this over this, negative 3 over 4. Now for the next case, n equals 8. Sine theta equals 5 over 13. Cos theta equals what? 4 minus 16, negative 12 over 13. So tangent theta is negative 5 over 12. Now we should find maximum of 116 tangent square theta. So we should maximize absolute value of tangent theta. So let's check which of them is greater, 3 over 4 or 5 over 12. Now here it will be 9 over 12. Multiply both numerator and denominator by 3. So this one will be greater. So the answer is 160 times 3 over 4, negative 3 over 4 squared, which will be 160 times 9 over 16, 16, 16. You have 10 here. So maximum, the answer equals 90. So it will be part choice B. Singapore Mathematical Olympiad SMO 2021 senior section first round problem number 5. Select all the inequalities which hold for all real values of x and y. For each one, you should try to create some squares. Like, for example, this one. It is equivalent to 0x minus 1 over 2 squared. Plus, it will be y squared. So here we have what? X squared minus x. You take all of them to the right side. So it will be x squared minus x plus 1 over 4 negative 1 over 4. So you can easily see that it has counterexample. If x equals 1 over 2, y equals 0, then it will be negative 4 greater than equals 0. So it is wrong. This one is equivalent, that 0 is less than or equal x minus y over 2 squared. We have x squared minus yx plus y squared over 4. So you can say plus 3. It is exactly this. We know it is always correct. So the first one wrong. It is correct. This one. It is equivalent that 0x minus 1 over 2 squared plus y plus 1 half squared. So plus 1 over 4 plus 1 over 4 minus 1 over 2. So here, if you consider x equals 1 over 2, y equals negative 1 over 2, then we have again contradiction. And we can also replace. Here it will be 1 over 4 plus 1 over 4, 1 over 2. But 1 over 2 minus 1 over 2 is 1. So it is wrong. Now let's consider this case. It will be 0 less or equal. For this one, let me write this one here. 0 less than or equal x minus, let's start with y. So if I want to find this, I can say, okay, x minus y squared. Then I say, okay, over 2. I have x squared, y squared minus 2xy over 2. So I create this. And then the next one, y minus 1 squared over 2. So negative y, negative xy we've created. X squared over 2, we have x squared over 2 is left. Y squared over 2, y squared over 2, y squared. And here it will be what? Negative xy, we have negative y. Here we have plus 1 over 2, so you should write negative 1 over 2. If I want to find counter example, I say x equals y equals 0. Let's see, can we find counter example here? If we want to reach all of them 0 from here, x equals y, x0, here y1. So we can't reach all of them 0, but for example, we can say if x is 0 and y is 1/2. So we have what? 1 over 4 over 2, 1 over 8, 1 over 2 squared over 2, 1 over 8, minus 1 over 2, it is 1 over 4, and minus this. Here we have contradiction because it will be negative 1 over 4 contradiction. Also, you can check this example. In the main inequality, you say, okay, y 1 over 2 x is 0 less than or equal 1 over 4, and that's contradiction. Now, the last part, v. You say, okay, x squared, x minus half squared, you create x squared and negative x, plus y minus half squared, and you have 1 over 4, 1 over 4 minus 1 over 4 minus 1 over 4, and also here is 1. So if you consider 1 minus 1 over 2 will be 1 over 2 plus, so we can say it is always positive. And so here it was bad, it is good. So second one, third, fourth, fifth one are good. These two things. So the answer is E. That these two cases are correct. Singapore Mathematical Olympiad SMO 2021 senior section first round. Problem number 6. Let x be the integer such that x equals 5 to the power of this term root 2 plus 4 log 5 in base x. Determine the value of x. Okay, as I said, the definition, let me call this one c log 5 in base x. So 5 is better to if we consider 1 over c equals log x in base 5, it will be. There are around, I think, 10 important formulas in logarithm. If you want to know all of them, or also other ideas, as I said, feel free to send message to my WhatsApp number in the description. Now here, the definition is what? It is the number that if you raise 5 to the power of that, 1 over c, it will be x. So you can say, okay, 1 over c equals 5 to the power of 2 plus 4 log 5 to the power of x. And x is an integer, it's positive integer here. We can conclude 1 over c equals 2 square root of 2 plus 4. We consider this is c, 4c. Then we can say, okay, 1 over c squared equals 2 plus 4c. And if we multiply both sides to c squared and take all things to right hand side, it will be 4c cubed plus 2c squared minus 1. When you see these types of problem, try to replace c with some thing to reach the answer, because the degree is greater than 2, you should find at least one root. If we check, we see that, okay, it is for integers you can't reach answer because it is even, it is odd. You can replace d with 1 over c, then it will be better. This idea is so much useful in SMO problems. You say, okay, it's 0, 4 over d cubed plus 2 over d squared minus 1. If we multiply by d cubed, we will have 4 plus 2d minus d cubed. Then we have d cubed negative 2d. Multiply both sides by negative 1, negative 4 equals 0. Now if we check, if we replace d with 2, it will be 0. So it is d minus 2d squared minus 2d squared plus 2d minus 4d plus 4 minus 4d. You should reach negative 2d, so you write plus 2 and it will be 0. So d from this d is 2. In this discriminant is 4 minus 8, which is less than 0, so the answer is d2. When d is 2, so c is reciprocal of that 1 over 2, so 1 over 2 is what? Log 5 over in base x. So log x in base 5 is what? Is 2. So we can say what? It is a number that if you raise 5 to the power of that, which is 2, it equals x. So x equals 25. And the problem says what? Says determine the value of x. So the answer equals x equals 25. Singapore Mathematical Olympiad SMO 2021 senior section first round. If cos A minus cos B equals 1/2 and sin A minus sin B equals negative 1 over 4, find the value of 100 times sin A plus B. So you should know sum or minus of cos and minus of sine. You should memorize the formula. Change, for example, plus or minus to product. They are very useful in Singapore problems. I use them. If you have any question about the solution, as I said, feel free to send message to my WhatsApp number here and also in the description. So cos A minus cos B equals, you say, okay. Let's write, we can say 2, it will be negative 2 sine A plus B over 2 sine A minus B over 2, which equals 1 over 2. And for the next one, sine A minus sine B equals 2 cos A plus B over 2 times sine A minus B over 2, which equals negative 1 over 4. If we divide, then 2 negative will be cancelled, and this 2 sine A minus B over 2 will be cancelled. We have what? We have tangent A plus B over 2. 2 will be cancelled. Here 1 over 2, 1 over 4 equals 2. As I said, there is important way, there is a useful way. You say, okay, when we have tangent something, you write 2 over 1. So you say 2 root 5 and 1 over root 5. So it is plus or minus. And you can check that if sine A plus B over 2 negative, so here negative, positive. So you can conclude the sign of sine A minus B over 2. So we consider both things. It is 2, or for both of them we consider negative. So it is sine A plus B over 2. The denominator is cos A over A plus B over 2. But we want what? We want 100 sine A plus B, so you can say, okay, it is equal to 50 sine A plus B over 2 times cos A plus B over 2. And you say, okay, the product of them will be positive in either they are positive, each of them, or negative. Product will be positive. It will be 50 times 2 times 1 over 5, which equals, if you divide by 5, it will be 20. Sorry. Here, 100 sine this is 2 times this. So let's correct this one. 5. It will be 200. It will be 200. 2 over 5. If we divide, it will be 40. So the answer equals 8. Singapore Mathematical Olympiad SMO 2021 senior section first round, problem number 8. Find the constant in the expansion of this term. Now we say, okay, suppose that we select alpha here, then we select 6 minus alpha because the degree is 6, here beta 10 minus beta. We want to find the constant, so alpha it is over 3 plus minus, because it is the power is negative 1 over 2 minus 6 minus alpha over 2 plus beta over 2 minus 10 minus beta. It equals 0. Now, if we multiply by 6, then we have 2 alpha minus 3 times 6 minus alpha plus 3 beta minus 6 times 10 minus beta equals 0. So 2 alpha here, alpha 3 alpha plus 2 alpha is 5 alpha, beta beta 3 beta plus 6 beta plus 9 beta equals the constant negative 18, negative 60, which will be what? Negative 78. Or you can say it equals 70. Now, we know 3 divides this, 3 divides this, so 3 divides 5 alpha, so 3 divides alpha. Alpha is between 0 and 6, so alpha can be 0, 3, or 6. If alpha equals 0, then 9 beta equals 78, and contradiction. For this case, if alpha equals 3, then 9 beta equals 78 minus 5 alpha, which is negative 15, is 363, so beta is 7. Let's check also this case. In this case, 9 beta is 78 minus 5 alpha, which is negative 30, is 48. That's a contradiction. So here alpha is 3, beta is 7. So it will be constant, x will be cancelled, but the coefficient or constant term is 6. Choose 3 because alpha is 3, beta is 7. You can say 10 choose 7 or 10 choose 3. So it is our answer. If we calculate this term, let's see, it will be what? 6 choose 3, it will be 6, 5, 4 over 3 factorial 6 times 10, 9, 8 over 6. Here you can say, okay, if we divide, this is 4, this is 3, this is 20, this is 12, 12 times 2, 24, and we have 2 zeros. So the answer equals 2,400. SMO 2019 senior section first round problem number 9. A quadratic polynomial p of x equals ax squared plus bx plus c where a is not 0 has the following properties: p of n equals 1 over n squared for all n equals negative 1, 2, 3. Determine the smallest positive value of k where k is not 2 and 3 such that p of k equals 1 over k squared. Okay, so p of negative 1 is, let me check for these three terms, is 1, p of 2 is 1 over 4, p of 3 is 1 over 9. P of negative 1 is 1, so we can say a minus b plus c is 1. P of 2, which will be 4a plus 2b plus c is 1 over 4. And p of 3 is 1 over 9. So you can say, okay, 9a plus 3b plus c equals 1 over 9. Now, if we subtract this minus this, then we have what? 3a plus 3b is 1 over 4 minus 1, which is negative 3 over 4. So a plus b equals negative 1 over 4. Now, if we subtract this from this, 9a minus 4a is 5a plus b equals 1 over 9 minus 1 over 4, which equals 36. 4 minus 9, which equals negative 5 over 36. Now, if we subtract this from this, 5a minus a 4a, which equals negative 5 over 36 plus 1 over 4. If we use common denominator, it will be negative 5 plus 9, which will be 4 over 36. So a is what? A is 1 over 36. Now we find b. B is what? B is negative 1 over 4 minus a, which is negative 1 over 36, which will be 36. Negative 9 minus 1, negative 10 over this, which will be negative 5 over 18. And now we find c. C is what? C is from this equation 1 minus a plus b, which will be 1 minus 1 over 36 plus b, which will be negative 5 over 18. If we use common denominator, 36. 36 minus 1 minus 10. Minus 11, and it will be 25 over 36. Now let's replace. P of x is what? Ax squared plus bx squared plus c. So P of k is ak squared. It's 1 over 36k squared plus bk, negative 5 over 18k, plus c, which is 25 over 36, equals what? Equals 1 over k squared. Now we want to find k. We know for negative 1 and 2 and 3 it works. So k, negative 1, 2 and 3 works. So we want to find the other one. If we multiply both sides by 36k squared, then we have k to the power of 4 minus 2 times 5, 10 k cubed and 25k squared, and 36 times this will be negative, if you take it to the left hand side, negative 36 equals 0. So if we check negative 1, it must be 0. 1 plus 10, 11. 11 plus 25, 36. Okay, so you factor from k minus k plus 1, because when k minus 1 is root, k minus minus 1 is a factor. It is k cubed, then you have plus k cubed, you write negative 11k squared, then you have negative 11k squared, you should write plus 36k, then you have minus 36k, plus 36k, you should cancel that, you write negative 36, it equals 0. Now, you factor in this case from k minus 2, it will be what? K squared, negative 2k squared, minus 9k, plus 18k, then you want 18k again. So you write what? If we consider plus 18, then we have 18k again, 36k, negative 36 equals 0, and the last one is k plus 1, k minus 2. You factor from k minus 3 because 3 is root. It will be k minus 3 minus 6 is 0. So the other answer is k equals 6. Singapore Mathematical Olympiad SMO 2021 Senior Section First Round, problem number 10. The figure below shows a triangle ABC such that AD, let me copy and paste in other place. Okay, triangle ABC such that ADBE are altitudes, so it is 90 degree. It is 90 degree to the sides B, C, and C respectively. The lines AD and B intersect at H. Determine H is orthocenter. Determine the area of the triangle ABC. If AH equals 50, DH equals 18, and BH equals EH. For this problem, we use Menelaus's theorem, and also we use some cyclic quadrilaterals. So if you don't know Menelaus's theorem or have any question about the other things, because Menelaus's theorem is very important, and also there are around, as I said, 50 important ideas and formulas in geometry. If you want to know them, feel free to send message to my WhatsApp number here. Okay, so let's solve this problem. We say if we consider triangle BHD, let me write here, triangle BHD and AEC are collinear, then we use Menelaus's theorem. So let's see, we have what? AH is 50 over AD, which is 8, times CD over CB times the last one, EB over EB over which equals 1. Now, if we simplify, we can say, okay, E over is twice by the assumption of the problem. It's 2. And then you can divide this by 234. You can divide it again 1725. So you understand that CD over CB is 17 over 25. Now, also, you know this angle is what? This angle is 90 minus C. This angle is what? 90 minus C. So by two angles, you can say triangle. It is so much important, this similarity of these two triangles, because we can conclude other things that are important, but in this problem, we don't need them. ADC. Now you can say, okay, BD is C here over AD equals BH, hypotenuse, over AC, which is B, BD, BH, and HD over DC. Now, for example, suppose BD is Y, DC is Z. We want to find the area. We know AH is what, so if we find A, then the problem will be solved. Now, let's check. Here you can say BD over AD. AD is what? AD is 68 equals HD, which is 18 over DC. So here we can say, because BD is Y, CD is Z, so CD is what is Z over DC is Y plus Z equals 17 over 25. And for this part, if we cross multiply BD times DC, YZ equals 18 times 68. This is so much important in any triangle. BD times DC equals DH times DA. And a special case of that happens when we have right angle triangle. You know this, that this times this equals this squared. General case of that is here, BD/DC. Let me write it with other color. It is so much important. BD times DC equals DH times DA in general triangle, but in right angle triangle, it will be a special case of this theorem that this times this equals, because H and A are same point, it will be this squared. Now, let's do the rest of that. Here, because we know the product of YZ, if you want to find relationship, the ratio Z over Y is 17 over 25 minus 17, which equals 17 over 8. Now, if we replace here, you can say, okay, Z is what? Z is 17 over 8 times Y. Now, if we replace it here, we can say Y times 17 over 8 times Y, 18 times 68. Now, 17, it will be 4, so Y squared equals 8 times 4, 32. We can write 18, 2 times 9. It will be 64, so we can say, okay, Y equals 8 times 3, which is 24. And Z is what? Z is 17 over 8 times 24, because of this expression here, called this star. You can say, okay, 8 divided by 8, 351. So A is what? A is Y plus Z, which equals 75. And the area of this triangle is A times AH. AH was what? 50 plus 18, 68, all over 2. And if we divide, it will be 34. You can say, okay, 34, answer 2 from here. Okay, so let's multiply. 34 times this number. 75. 4 times 5, 22. 28, 30, 15, 1, 2, 2. And it will be 0, 5, 5, 2. So the answer equals 25, 50, the area of triangle ABC. For Mathematical Olympiad SMO 2021, senior section first round, problem number 11. In the figure below, GCB equals 90. So let's show it here. Let's draw with blue. GCB is 90. ACE is also 90. It's obvious. If it's dark linear means. DFE is 90. GBC is theta. EAC is theta. EDF is theta. Also, GB equals 6. GB equals 6. AE equals 10. AE equals 10. DE equals 8. And let us note the sum of the areas of the triangles ABC plus CDE. Find the maximum possible value of S. Okay. Area of ABC equals what? Equals AC times BC over 2. Area of CDE equals DF times C over 2. We want to find all these for length in terms of theta and then try to differentiate in terms of theta and find the maximum possible value of S. AC is what? If you consider triangle ACE, it is 10 cos theta. Let me write there 10 cos theta times BC. BC is what? BC is 6 cos theta in triangle BGC. 6 cos theta all over 2 plus DF. DF is 8 cos theta. 8 cos theta times, let me write a little better this one. Okay. Cos theta times C in triangle ACE, it is 10 sine theta over 2. Now we can say, okay, the first part is what? The first part is 2. If we divide both of them by 2, then we will have 20, 30. 30 cos squared theta plus 8, 2, it will be 40. 80 over 240 cos theta sine theta. So we know 2 times cos theta sine theta equals sine 2 theta. So I write 30 cos squared theta plus 20 sine 2 theta. Now I differentiate from S. S prime will be 60 cos theta and negative sine theta plus 20 cos 2 theta times 2. And then it equals 0. So here it will be what? Negative 2 times this will be sine 2 theta. So negative 30 sine 2 theta. And plus 40 cos 2 theta equals 0. So you can divide both sides by 0. And we can conclude, okay, 3 sine 2 theta equals 4 cos 2 theta. Then we can conclude tangent, or let me write at first sine 2 theta over cos 2 theta. Sine, it is 2 theta. Sine 2 theta over cos 2 theta equals 4 over 3. And then we can say it is tangent 2 theta. The formula for tangent 2 theta is 2 tangent theta over 1 minus tangent squared theta. You can consider tangent theta as x. So 4 times 1 minus x squared equals 3 times 2, 6x. So we divide by 2, it will be 2, it will be 3. And then take all things to right hand side, it will be 2x squared plus 3x minus 2 equals 0. So you can say x equals negative 3 plus minus b squared 9 minus 4ac, which will be 16 over 2a. So we can say now x equals negative 3 plus minus 5 over 4. So it is 5 minus 3 over 4, which will be 2 over 4, or negative 8 over 4, which will be negative 2. We know theta is between 0 and 90, so tangent is positive, so we reject this one. So tangent theta is 1 over 2. Because we know theta is between 0 and 90 degree, let me tell you a very fast way to find sine theta and cos theta. You say, okay, 1 squared plus 2 squared is 5. 1 over root 5, 2 over root 5. it is sine theta, it is cos theta. If you want to learn these things, quickly solve them and how to work with trigonometric thing, as I said, feel free to send message to my WhatsApp number in the description. Also, you could write equation sine squared plus cos squared equals 1 sine over cos is 1 over 2. You will reach exactly the same thing. Now we found sine theta is what, cos theta is what, so we should replace in the first equation that we had here. Let me copy this part. Control C. And now we place sine theta and cos theta. So the answer of this part equals 30. Cos squared is 4 over 5 plus 40. Cos times sine, it will be 2 over 5. 5, this 6, 5, this 8. So it will be 24 plus 16, which equals 40. So the maximum S and the answer of this problem equals 40. SMO 2021 senior section first round problem number 12. Find the sum of all the solutions to the equation cube root of x minus 110 minus cube root of x minus 381 equals 1. For solving this problem, you should know an important identity. The identity is what? A cubed plus b cubed plus c cubed equals a plus b plus c, a squared plus b squared plus c squared minus ab minus ac minus bc plus 3abc. There are some important identities you should know. And if you want to know all of them, as I said, feel free to send message to my WhatsApp number in the description. If a plus b in this equation, c equals 0, then we can conclude what? A cubed plus b cubed plus c cubed equals 3abc. Now here, consider this part cube root of x minus 110 minus cube root of x minus 381 minus 1 equals 0. Each of them, you consider a, b, c. The first one, a is this, b is this, c is this. So because some of them equal 0, we can conclude x. This idea is so much useful when some of these things equal 0. You have cube root, you can raise to the power of 3. So a is this, so a cubed is this, plus b cubed equals negative x minus 381 minus 1 equals 3 times cube root of x minus 110 and negative cube root of x minus 381 times negative 1. Now, if we cancel these two terms, then we have what? 381 minus 111. And it will be, so it will be 381 minus 111, negative, negative, positive. It will be 3 times cube root of 110 and x minus 381 cube root of that. Here it will be what? 8 minus 1, 7, 3 minus 1, 2. You can cancel, divide both sides by 390. And then we can conclude x minus 110 times x minus 381 equals 90 cubed. Now, the problem says what? Find the sum of all. Always pay attention. The problem wants what? We don't need to find x. We want to find sum of all the solutions to this equation. So you say, okay, it is equal to x squared and then plus x negative 381 minus 110 and plus 110 times 381 minus 90 cubed equals 0. So we know the sum of roots of this quadratic formula is negative b over a. A is 1, b is this, so it will be 381 plus 110. It will be 194. So the answer equals 491. SMO 2021 senior section first round, problem number 13. If f of x equals this, where x is greater than or equal -2, less than or equal to, find the maximum value of f of x. So when you have this function and you want to find maximum value of f of x, you should consider endpoints and also differentiate from this. One useful and general idea is this. If x equals -2, then f of x equals what? Let's calculate. -440, it will be -2, -2, -4, 3 minus 2, 1. The power of 2, it will be 16. If x equals 2, f of x equals 2, 2, 4, 4 plus 4, 8, plus 2 minus 2, 0, so 0 over 5, 0, it will be 64. So we found 64. We want to check that do we have any x between -2 and 2 that the f of x is greater than 64. So let's check. If we differentiate from f prime will be 2 times 2x plus 4 plus x minus 2x plus 3 times differentiate from this part 2 plus differentiate from numerator 1 times x plus 3 minus x minus 2 times this over x plus 3 squared. Now, if we want to say it is equal to 0, consider this. If it is equal to 0, then we consider, okay, then f is 0, but it is not maximum. So let's only consider this case. In this case, 2 times x plus 3 squared, x, negative x, they will be cancelled. 3 minus 2, 3 plus 2 will be 5 equals 0. And so we can see it is not possible because it is always greater than equal to 0. It is positive, the left side, the right side 0. So contradiction. So the maximum f equals 64. SMO 2021 senior section first round, problem number 14. Given that d equals this term, for values of x and y, find the minimum value of d to the power of 8. So if we check this term, always inside the square root there are greater than equal 0. So we don't have any endpoints. We only need to differentiate. Because we have a square root here, we can at first consider d squared, which equals x squared plus y minus 1 squared plus x minus 1 squared plus y squared. If we want to maximize d to the power of 8, we should maximize d to the power of 2d squared. We call this one a, so a prime. If I differentiate from this term, so at first let's differentiate from, let me write like this, from a in terms of x, it should be 0. So I say what? It is 2 times x squared plus y minus 1 squared, 2x here, 2 will be cancelled, plus then x minus 1 square root 2x minus 1, 2 times this, 2 will be cancelled. We have x minus 1 squared plus y squared equals 0. And then we say, okay, x over x squared plus y minus 1 squared equals 1 minus x over x minus 1 squared plus y squared. If we raise both sides to the power of 2, then we have x. You should at the end pay attention to the sign of both sides. And okay, x squared times x minus 1 squared plus y squared equals 1 minus x squared times x squared plus y minus 1 squared. Now you can see that you can cancel these two terms from both sides. So we conclude what? X squared y squared equals 1 minus x squared 1 minus y squared. So we conclude absolute value of xy equals 1 minus x times 1 minus y. Absolute value of this. So here, because we should consider the sign, I say what? I say if I want to minimize d to the power of 8 or minimize d squared, so if x is greater than equal 1, so if you increase it, it will be increased, it will be increased, so it will be increased. So you understand that x should be less than or equal 1, because if, for example, x is greater than 1, then if you increase x, then d squared will be increased, and that's a contradiction if you consider the minimum case. So x is at most 1. Also, you can say if x is less than 0, then if you change x to 0, then you decrease this, also you decrease this, so d squared will be decreased. So again, by minimum d, you have contradictions, so we can conclude x is at least 0. So x is between 0 and 1. Similarly, you can consider y is also between 0 and 1. Because we proved they are between 0 and 1, so we can conclude, let me call this part, we can call this part star. Then by star, we can conclude xy equals 1 minus x, 1 minus y. And it equals 1 minus x minus y plus xy. If you can cancel xy from both sides, so x plus y equals 1. And if we consider this case, let's replace in d squared. So here, let's see a equals what? X squared plus y minus 1 is negative x, you can replace with x squared because here is x squared. And then you can say here, it is x minus 1 squared plus x minus 1 squared. So we can say, okay, it is the first one, because we said x is positive, it will be x root 2 plus x1 minus x root 2, because here we know x is between 0 and 1, so absolute value of x minus 1 is 1 minus x, and we can factor from root 2, it will be x plus 1 minus x can cancel, which equals 2. And d to the power of 8 is what? Is d squared to the power of 4. D squared is root 2 to the power of 4. It will be 2 squared and it will be 4. So the answer equals 4. SMO 2021 senior section. First round, problem number 15. Find the minimum value of this term where theta is strictly greater than 0, less than pi over 2. So we differentiate from this term, it will be 8 times negative, because it's sine 2 theta to the power of negative 1, sine 2 theta squared times, differentiate from this, cos 2 theta, and then times 2 plus 12 times 1 plus tangent 2 theta, it equals 0. Endpoint, we don't need to consider endpoints now. We say, okay, we know sine 2 theta is not 0 also. So if we divide both sides by, let me tell you, by 4, then we have 3, and take it to the right hand side, then 3 times 1 plus tangent squared theta equals negative 2 cos 2 theta all over sine 2 theta squared. Now we know that it is equal to what? 1 plus tangent squared theta is 1 over, so here we have 3, 1 over cos squared theta. Oh, sorry, because we take it to the right hand side, the sign will be positive. Now let's cross multiply, we will have 3 sine squared 2 theta equals 2 cos 2 theta cos squared theta. You can say sine 2 theta is 2 times sine theta cos theta squared. It will be 3 times 4, 12. Sine squared theta cos squared theta equals 2 cos 2 theta cos squared theta. You can cancel both sides. These 2 cos theta, cos squared theta from both sides. Now, let's simplify. 2, 12 is 6. So 6 sine squared theta equals cos 2 theta, which equals 1 minus 2 sine squared theta. So we can say 2 sine squared theta take. Let's check it. Yes. Okay, so here we have two twos. I forget one of them, so let's write here 4, let's write here 4. And okay, if I place 4 here, then I have 4 here. Then because we have 4 here, you can divide by 4 both sides. So you have 3 here. And it will be what? It will be 3 sine squared theta equals 1 minus 2 sine this. And then we can say, okay, 5 sine squared theta equals 1. So it is 1 over 5. So we can conclude sine theta equals plus minus 1 over root 5. Now the problem says what? The problem says theta is between 0 and pi over 2. So sine theta and cos theta are positive. So sine theta is 1 over root 5. And we can say cos theta is 2 over root 5. And now the main expression, let me copy our main expression here. Copy. So let's see what we need. Sine 2 theta. Sine 2 theta is what? Is 2 times sine theta cos theta. It will be 4 over 5. And tangent theta is sine over cos, which will be 1/2. So if we replace 8 over 4 over 5, which will be 8 times 5 over 4 plus 12 this, it will be 6. If we divide, it will be 10 plus 6, which equals 16. So the answer equals 16. Also, if you want to make sure that, for example, in some problem it is maximum or minimum, because maybe it's minimum, you can check, for example, for theta 30 degree and see that the answer is maximum. SMO 2021 senior section first round problem number 16. Determine the largest angle theta in degree where theta is greater than equal 0, less than or equal 360 such that this equality is satisfied. For solving this problem, I change sine this plus sine this to product, also these two signs, some of them to product, also this cos and some of these two cos to product. Sine alpha plus sine beta equals 2 sine alpha plus beta over 2 times cos alpha minus beta over 2. So if we apply this on the left hand side, we have what? 2 sine this plus this over 2 will be theta plus 18 plus 234 will be 12, 1, we have 5, 2, 5, 2, which will be 1, 2, 6 times cos. Their difference 2, 3, 4 minus 18 over 2. It will be 14 minus 8, 6. 2 minus 1, 1, and 2. So it will be cos this over to 108. And now let's apply for these two things, 162 and 306, plus 2 sine sum of them over 2 sum of them, 306 plus 162, which will be 864. Sine of sum of them, theta, plus this over 2, which will be 234, cos the difference. If we consider cos the difference, it will be 306 minus 162, which is 4, 4, 2, we have 1. Cos 72, it is over 2, equals, if we want to use this, cos alpha plus cos beta equals 2 cos alpha plus beta over 2 times cos alpha minus beta over 2. So it equals 1 plus 2 cos sum of them over 2, which will be theta plus 180 cos their difference over 2. 300 minus these two, 4120. Cos 120 is negative cos 60. And it will be negative 1 over 2. So it will be 1 minus cos theta plus 180, and it is negative cos theta, so it will be 1 plus cos theta. Here we can, let me write the rest of that with black. This one you can say cos 72, we have it is negative cos 72. And from left hand side, if we factor from 2 cos 72, we have negative sine theta plus 1 to 6 and plus sine theta plus 2, 3, 4. It equals 1 plus cos theta. Now here, if we want to apply, if we want to change it to product again by this rule, but here we have something minus this, so you change beta to minus beta. It will be 2 cos 72, then times 2 sine. Sum of them. It will be theta plus 2, 3, 4 plus, take minus inside. It will be plus sine negative this. It will be minus theta minus 1 to 6 all over 2 and cos their difference, because minus here their difference will be their sum. Now it will be theta plus 2, 3, 4 plus 1 to 6 over 2 theta plus theta over 2 is theta. It equals 1 plus cos theta. Now here we cancel these two thetas. Also here it will be 10, 1, 5, 6, and then 360. And for this case, 14 minus 6 is 8. Here we have 2, 2 minus 2, 0. And 2 minus 1, 108. So we have what? 2, 2 is 4. 4 cos 72 sine 108 over 254. And here cos theta plus 180 equals 1 plus cos theta. Now we can say, okay, it is what? Negative cos theta. So the problem says find what? The problem says find largest angle theta in this case. So we say, okay, cos theta is, if we factor, it will be, take it here, it will be negative 4 cos 72 sine 54 minus 1 equals 1. So cos theta is negative 1 over 4 cos 72 sine 54 plus 1. Now we should focus on finding these things. Cos 72. So cos 72, we should focus on finding cos 72 sine 50. Cos 72 equals sine 18. And sine 54, you can say it equals cos 36. So cos 36 equals this part 2 cos, or let's say, because we want to write in terms of this, 1 minus what? 1 minus 2 sine squared 18 degrees. Now we consider, for example, sine 18 equals sine, for example, gamma. We know 5 times gamma equals what? Equals 90 degrees. So we can say what? We can say, for example, if we consider 2 lambda equal 2 gamma equals 90 minus 3 gamma. Now we say, okay, if we consider sine from both sides, sine 2 gamma equals sine 90 minus 3 gamma equals cos 3 gamma. Now we say, okay, the left hand side is 2 sine gamma cos gamma equals this one. You can say it is gamma plus 2 gamma. So we can say cos gamma cos 2 gamma minus sine gamma sine 2 gamma. And we can write it like this. It's 2 sine gamma cos gamma. And for this case, we can say it is cos 2 cos squared gamma. Or let's write in terms of 1 minus 2 sine squared gamma. So if we factor from cos gamma, we will have 1 minus 2 sine squared gamma, and for gamma it will be negative 2 sine squared gamma. Now because we know gamma is 18, so cos gamma is not 0, you can cancel it from both sides. So we have 2 sine gamma equals minus 4 sine squared gamma plus 1. Now, it is a quadratic function. We can take all things to the left hand side. 2 sine gamma plus 4 sine squared gamma plus 2 sine gamma minus 1 equals 0. So sine gamma is what? Is negative b plus minus b squared 4 minus 4ac, which will be plus 16 all over 8. And it will be negative 2 plus minus root 20 over 8. So it will be negative 1 plus minus root 5 over 4. And we know sine gamma, because gamma is between 0 and 90, is 18 degree. So it must be positive. So it is root 5 minus 1 over 4. Now we found sine gamma sine 18, root 5 over 4. So root 5 minus 1 over 4 here. If we replace, we have what? We have a root 5 minus 1 over 4. 1 minus 2 sine squared. It will be what? It will be 5 plus 1, 6 minus 2 root 5 over 16. Okay, so if we expand, we can cancel 16. It is 3. It is 2. And 1, 2 with this, it will be 4. So it will be, let me calculate this part. It will be 4 minus 3, 1, minus minus plus, plus root 5 over 4. So if you multiply them, it will be 5 minus 1, 4, 4 over 16, which equals 1 over 4. Now, here it will be what? Negative 1. 4 times 1 over 4 is 1 plus 1. It will be 2, negative 1 over 2. Now, if you consider the unit circle from 0 to 180, the angles here that we have is about 120, 90 plus 30. And these angles, their cos equals negative 1 over 2. So the first one is what? The first one is 120, and this one is negative 120. So negative 120 is what? 316 minus 120 equals 240. So the answer equals 240 degree. SMO 2021 senior section first round. Problem number 17. Let O be the circumcenter of the triangle ABC. Let me write it in other place. Okay, and ABC is 30. So this angle equals 30. Let D be a point on the side BC such that the length of AD is the same as the radius of the circle. So it is equal to this. Determine the value of ADO. ADO, okay? Alpha OAB. OAB, it is 10. So it is 10. Now, we want to find alpha. We know it is alpha. It is also alpha. AC is here. We have an important formula in geometry that radius is A over 2 sine A. As I said, there are around 15 important formulas. If you want to know exactly them and how to prove them, the proofs of them, you should memorize them. So let's feel free to send a message to my WhatsApp number in the description. Now here, R is this. Now I want to find AC. If I want to use this formula, A is 2R sine alpha, so AC is 2R sine 30. Sine 30 is 1/2, so it equals R. So we understand AC is also R. And the other things, if we connect OB, let's see. Let me erase this part. We know it is 30. So if I connect B, let me change it to line. Okay, we know it is radius, it is also radius. So this angle will also be 10, this angle will be 20. And this angle is beta. Let me call also it is beta because there are isosceles triangle. And we can say that, okay, this angle is what? This angle is 180 minus, for example, 2 beta. This angle is 180 minus 2 alpha. And in triangle ACB, if I add all the angles, the first one here is beta plus 180 minus 2 beta, 180 minus 2 alpha plus 10 will be 360, 370 minus 2 beta minus 2 alpha equals plus 30 equals 360. Now we can say what? Beta negative 2 beta will be negative beta negative 2 alpha equals, and let me write, plus 400 equals 360. Now 400 minus 360 will be 40. 40 equals beta plus 2 alpha. Sorry. Here the sum of angles is 180. So if I correct this, 400 minus 180 is 220. Also here we can say, okay, OA is radius. We proved AC also radius. So if I connect this, I understand what? I understand OAC is equilateral triangle. So this angle is 60 degree. So 180 minus 2 beta plus 180 this angle. I want to calculate this. Plus 180 minus 2 alpha equals 60. So here we can say, okay, 360 minus 2 alpha minus 2 beta equals 60. So 360 minus 60, 300 equals 2 alpha plus 2 beta. You can divide by 2 alpha plus beta equals 150. We want to find what? We want to find ADO, which is alpha. So if I subtract this from this, then I have alpha equals 220 minus 150, which equals 70. So the answer is equal to 70 degrees. SMO 2021 senior section, first round, problem number 18. The function f satisfies f of x times f of x plus 1 equals x squared plus 3x for all real numbers x. If f of 1 plus f of 2 equals 25 over 6 and 0 less than f of 1 less than 2, determine the value of 11 times f of 10. Okay, for solving this problem, we say, okay, f of 1 times f of 2, if we consider x equals 1 equals 1 plus 3, 4. F of 1 plus f of 2 equals 25 over 6. I consider f of 1 equals c. So now I want to find f of 1. So here c plus f of 2 is 4 over f of 1, which is 4 over c, equals 25 over 6. We multiply both sides by 6c. Then we have 6c squared plus this one is 24 equals 6c, 25c. Now we conclude 6c squared minus 25c plus 24 equals 0. Then we conclude c is 25 plus minus 625 minus 4ac, which is 4 times 6, 24. 24 squared is 576 over 2a, which is 12. And it will be 25 plus minus 15 minus 6, 9. And then it will be 11 minus 7, 4. And then 5 minus 5, 0. It's 12. So it will be 25 plus minus 7 over 12. Now it says what? It says it is between 0 and 2. If you consider plus, it will be 32 over 12, which is greater than 2. So it is c equals, or f of 1 equals 25 minus 7 over 12, which is 18 over 12. If we divide both numerator and denominator by 6, it will be 3 over 2. Now we want to find f of 10. We say, okay, let's use this expression. Let me copy this. And then we say what? We say paste. Okay. We say f of 10, f of 9 times f of 10. And times 1 over, let's start from greater 1. We say f of 10 times f of 9 times 1 over f of 9, f of 8. Somehow we can say it is similar to telescoping rule. Then here telescoping product, f of 8 times f of 7 over 1 times 1 over f of 7 times f of 6. And we can say what? We can write like this. And the last term, f of 2, f of 1, here like even, odd, odd, even. So f of 2, f of 1 we have here. And it equals what? Let's see. F of 10, f of 9, it is 9. And it is what? X times x plus 3. So here x is what? X is 9. So it will be 9 times 12 times 1 over what? Here it is 8 times 11 times, it is what? It is 7 times 10. And this one will be what? 1 over 6 times 9. And then you write like this, all of them. And the last one, f of 2, f of 1 equals 1 times 4. And now we can see what? We can see, okay. 9, 7, you have 9, 7, the odd part. 5, 3, 1. Times 12, 10, 8, 6, 4, the even part. And now here, you can say before this also, it is what? 1 times 4, it is 2 times 5. So the even part is 8, 6, 4, 2. The odd part is 11, 9, 7, 5. Now, here we know what? We know it will be cancelled, it will be cancelled, it will be cancelled. And it will be cancelled like this. So it is f of 10 times f of 1. And we know f of 1 is what? So we can find f of 10. So if we cancel 8, 6, 4 here, we cancel. 9, 7, 5, we cancel. 9, 7, 5. Now here we have 2, we have 6 here. So it will be what? It will be 6 times 3 times 10, 180 over 11. Now it is what? It is f of 10 times f of 1 equals 180 over 11. We want 11 times f of 10. And also f of 1 is what? 3 over 2. So f of 1 is 3 over 2. So you say f of 10 equals 180 over 11 times 2 over 3, and 11 times f of 10 equals 180 times 2 over 3. If we simplify, it will be this, and it will be 120. So the answer equals 120. SMO 2021 senior section first round. Problem number 19. Find the value of this term. So here I say, okay, 1 over sine squared 0.5 minus, I write this, sine squared 0.5 over cos squared 0.5. Then I can see if I consider the common denominator, then I will have this, it will be sine squared 0.5 cos squared 0.5 cos squared 0.5 minus sine squared 0.5. Now I can say the first, the numerator is cos 1 degree, and the denominator will be what? Will be sine times cos is sine 1 over 2. So it will be sine squared 1 over 4. You can see, okay, if you want to write all of them, we can solve it this way. So look, in any problem, you can check different cases. But if we consider 1 over sine squared 0.5 minus tangent squared this plus what is 90? 89.5 degrees. So you can say it is equal to 1 over sine 0.5 degree minus cotangent or 1 over tangent 0.5. So you can write it is equal to cos squared 0.5 over sine squared 0.5 degree. So you can write this 0.5 degree 1 minus cos squared this angle. It will be sine squared 0.5 over this. It will be 1. So we consider what? Also we consider 1 over sine squared 89.5 minus tangent squared 0.5. And similarly, if we write the same things, it will be 1 again. So let me check. For example, suppose we call this one a 0.5. So a 0.5 you consider plus a 89.5 equals to a 1.5 plus a it equals 79.5 again equals 2. And you write all these things. So you conclude that, let me write with this way, a 0.5, a 1.5, a 2.5, then a, for example, oh, sorry, it's 89, 88.5. 88.5 here. So we can say what? We can say a 87, for example, 0.5 plus a 88.5 plus a 89.5. For example, it equals t. Then you consider, okay, t, write it in reverse order. A 89.5 to the last one here 0.5. We proved all of them are 2, so 2t equals 2 times. How many cases do we have? 0, 1 to 89. We have 90. So t equals 90. Now we should check for the other terms from 90.5 to 179.5. 90.5 to 179.5. We know that if we consider 90.5 to this number, let's consider, for example, sine 90.5. Here it was 1 over sine squared minus tangent squared. 1 over this squared minus tangent 179.5 squared. It will be what? It will be 1 over sine 90.5 squared. Then you subtract this by 90. It will be. For the rest of the problem, if you consider these two things, maybe it's useful, but I want to consider 90.5 with 0.5. So suppose for some 90.5 is alpha and beta is 0.5. Then 1 over, for example, sine squared alpha. The relationship is what? Beta alpha minus beta is 90. So this minus tangent squared beta. If you consider this, then we have what? We have tangent beta. Tangent beta is tangent alpha minus 90. You can say it is equal to negative tangent 90 minus alpha, and you can say, okay, it is negative 1 over tangent alpha. And you can say, okay, it's sine squared alpha minus, if you replace with this, negative squared will be cancelled, so negative for here we have cos squared alpha over sine squared alpha, and if you use common denominator, 1 minus this, sine squared alpha over sine squared alpha is 1. Also, if you write sine squared beta minus tangent squared alpha, it's what? Tangent alpha is tangent 90 minus 90 plus beta. It equals what? It equals negative tangent 90 minus beta, because the sum of them is 180. And then you can say, okay, it is negative 1 over cotangent beta, and you can use the same thing, and here also it will be 1. So here we said, okay, t is what? T is a 0.5 to 89.5, so 0.5, 1.5 to 89.5. Now it has a relationship with 90.5. This is 91.5, and it is now plus 90, 179.5. So we know some of them equals t. If some of them is L, you know t plus L, each of them is 2. So is 2 times, because it has two bonds, sine with tangent of this with sine of this, 2 times 90, which is 180. We've reached that t is 90. Here t is 90, so L is what? L is 90. The answer of the problem is what? Is t plus L equals what? So you can say it is equal to 180. SMO 2021, senior section, first round, problem number 20. Let A1, A2, A3 be these three distinct integers where 1000 is greater than A1, greater than A2, greater than A3, greater than 0. Suppose there exist real numbers x, y, and z such that these three equalities find the largest possible value of x plus y plus z. Now, if we consider first equation minus second equation, let's see what we have. It will be let's consider it is the first one, second one, third one. 1 and second, if we subtract, it will be a1 minus a2 times y, and x here minus this, plus a2 minus a1 times x, and z, this minus this a3 will be cancelled, plus z, a1 minus a2 equals 0. Now we say what? We say a1 minus a2 times y minus x plus z equals 0. From the assumption of the problem, a1 is strictly greater than a2, so it is not 0. So we conclude what? Y minus x plus z equals 0. So the first equation that we've reached, x equals y plus z. Now we consider second 2 minus third one. So we can say what? X, a3 minus a2 times x plus a2 minus a3 times z plus a3, because it's minus this, a3 minus a2 times y equals 0. Again, we say, okay, a3 minus a2 times x minus z plus y equals 0. And we conclude it is not again 0, because a3 is strictly less than a2. So x minus z plus y is 0. And we conclude z equals x plus y. If we use the first term, x equals, let me call this one star, and if you replace x with z plus y, y plus z plus y, you can cancel z. So we conclude y equals 0. And if y equals 0, then x equals z. Now, we use one equation and replace the things we've reached so far. So, first, a1 minus a2 times y is 0 plus a1 minus a3 times x equals a1 plus a2 plus a3. Now we say what? X equals A1 plus A2 plus A3 all over A1 minus A3. And we know Z equals this, Y equals 0. Then all equation will be satisfied because we've considered subtraction of each pair. Now the problem says what? Maximize, find the largest possible value of x plus y plus z. So x plus y plus z is what now? X plus y plus z equals y is 0, x equals z, so it is 2x. So you should maximize x. Because we want to maximize x, we should maximize numerator and minimize denominator. We know a1 minus a3. If we want to minimize, it is at least 2. And if we maximize, we consider it is 999, it is 998, so it is 997. In this example, we both maximize numerator and minimize denominator. It will be 999 plus 998 plus 997. And here it is x, we should find 2x. So the answer of the problem 2x is what? 999 plus this. 999 plus 997 is 2 times 998, so it will be 3 times 998. It will be 3 times 8, 24, 2, 3 times 9, 27, we have 229, 2, and 29. So the answer equals 2994. SMO 2021 senior section, first round. Problem number 21. The figure below shows a circle centered at O with radius 555 centimeter. If OA equals OB and RA over AS plus RB over BT equals 13 over 6, find OA. Okay, because the problem says OA equals OB, you consider it is X, OP is R, so you say it is, because we have R, big R here, let's write here R small r minus X. Also OQ is R, so it is XR minus X. We can say what? We can say RA times AS equals QA R minus X times this part will be R plus X, because it is R, it is X. So R minus X times R plus X, which R minus X is QA, R plus X is AP, equals R squared minus X squared. RB times BT equals what? Again, similarly, you can say it equals R squared minus X squared. Here, RAAS we have, so I multiply both RA and AS to RA over RA plus RB. It is 1, this fraction. RB over BT times RB over RB. It equals 13 over 6. Now, RA times RA is RA squared. RA times AS is what? R squared minus X squared plus. It is RB squared. Again, RB times BT equals R squared minus X squared. If you don't know why we have this, you should use similar triangles. If you have any problem with the solution, as I said, feel free to send message to my WhatsApp number in the description. So here, RA squared plus RB squared, you can write, and times 16 equals 13 times R squared minus X squared. So we have an important formula in median, and it's so much important. We solve many problems in SMO with that. In triangle ABC, MA, if MA is median, is B squared over 2 plus C squared over 2 minus A squared over 4. You should memorize this. Here, RO is median. Median in triangle RAB. So we can say what? We can say, okay, median RO. RO is what? Is R squared equals RB squared over 2 plus RA squared over 4 over 2 minus AB squared over 4, which is 2x squared over 4, which equals x squared. Now let's see what can we say. Here we say, okay, R squared, we have RB squared plus RA squared. We have 13 over 16. We have 2 here also, 32 r squared minus x squared minus x squared. Now we can say what? We can say, okay, this minus this, you take x squared to right hand side, x squared will be 1 plus 13 over 32, and r squared will be what? I'm sorry, here we have 6 here, so let's correct this, so it will be 6, so it will be 13 over 6, here will be 12. 13 over 12, 12. So r squared will be 13 over 12 minus 1, which equals 1 over 12 r squared over 12. If we multiply both sides by 12, then we have x squared. 12 plus 13 equals r squared. So x equals r squared over square root of r squared over 25, which equals r over 5. From assumption of the problem, it is 55555 over 5 equals 111. SMO 2021 senior section first round problem number 22. Find the number of real solutions x, y of the system of equations x cubed plus y cubed plus y squared equals 0, x squared plus x squared y plus xy squared equals 0. Okay, now if we subtract second one from first one, you say, okay, x cubed here we have, consider with this, consider y cubed with this one, and y squared with this one. So we have what? We have x cubed minus x squared y plus y cubed minus xy squared plus y squared minus x squared equals 0. So the first one, you say x squared x minus 1. If we factor from y squared, it will be y minus x. And from last one, it will be y minus x times y plus x equals 0. So you can factor from y minus x, then we will have negative x squared plus y squared plus y plus x equals 0. Now, for this part, you can say it is equal to y minus x times y plus x. Again, you can factor from y plus x, it will be y plus x times y minus x plus 1 equals 0. So we have three cases. The first case, y minus x is 0. So y equals x, if we consider in the first equation, then x cubed plus x squared equals 0. So you can say, okay, 2x cubed plus x squared equals 0. You factor from x squared, it will be 2x plus 1 equals 0. So the first answer here equals x equals 0 and y, because x equals y in this case, x equals y equals 0. So if it is 0, x equals negative 1 over 2, x equals y equals negative 1 half. And the problem says find the number of real solutions. So we check this. Let me copy this one and see. Do they satisfy the first equation? We've checked here and reached this. Now let's check for the second one. If x, y 0, it is okay. If x equals y negative 1, if we check second equation, it will be 1 over 4, negative 1 over 8, negative 1 over 8 equals 0. It will be negative 1 over 4, and that's correct. So we found two answers so far. Case 2. Case 2 is the case that y plus x equals 0. Y plus x equals 0, so you can say y equals negative x. If we check in the first equation, we have x cubed, negative x cubed, plus y squared, which is, you can say x squared equals 0. You can cancel, so x is 0. X is 0, y is 0. We've checked, we've reached this answer in case 1. We should find different answers. And the last case, y minus x plus 1 equals 0. Plus 1 equals 0. So you can say y equals x minus 1. And then if we replace in the first equation x cubed plus x minus 1 cubed plus y squared x minus 1 squared, it equals 0. And if we write, it will be x cubed plus x cubed minus 3x squared plus 3x minus 1 plus x squared plus minus 2x plus 1 equals 0. It's from the first equation, and if we simplify, it will be 2x cubed negative 3x squared negative 2x squared here, and 3x minus 2x plus x, and negative 1 plus 1 equals 0. And it will be what? It will be x times 2x squared minus 2x plus 1 equals 0. From first equation, you here you say, okay, x is 0, or the discriminant here is 4 minus 4 is 8 less than 0, so x equals 0. Then y equals what? Y equals negative 1. So the first equation will be satisfied because we've checked that. For x squared plus 2x x squared plus x squared y plus xy squared, we want to check it is what? X is 0, 0, 0, 0, it will be 0. So we found the third answer. So we have 3 answers. So the answer equals 3. SMO 2021 senior section first round problem number 23. The following 3x5 rectangle consists of 15 1x1 squares. Determine the number of ways in which 9 out of the 15 squares are to be colored in black such that every row and every column has an odd number of black squares. Okay, so in each column we have odd number of black squares. It can be 1 or 3. So because 1 or 3, 1 or 3, 1 or 3, and here, because we have 9 black squares, so only one way is possible. 3, if all of them are 1, then it will be 5. So 2, 3 you have, and 3 ones. So it will be 5. So at first, when 3, this means completely black. So without loss of generality, suppose that, for example, these 2 columns are black. So you say 5 choose 2 for 2 3s. Now, this column, this row, and this row are have odd blacks, and it is 1 1 1. So here also you should place 1, because if you place 3 of them, and how many blacks are left? 3. So in each column 1, in each row. If you don't consider these 2 columns, we have 3 by 3. We should have 1 1 here, 1 1 here in each column. So the first row has 3 cases. The second row, if you place this black here, so in the second row you should place here or here, because you can't place here. 3 times 2 times 1. So the answer equals 10 times 3 times 2, 6, equals 60. SMO 2021 senior section first round problem number 24. Let n be a positive integer such that 2021 and over 2021 plus n is also a positive integer. Determine the smallest possible value of n. So if we use divisibility, we can say 2021 plus n divides 2021, and if we multiply, we can say also 2021 divides itself, and then you multiply it by 2021, it will be 2021 squared plus 2021, and if you subtract, we calculate 2021 plus n divides 2021 squared. And if you prime factorize 2021, it's 43 times 47. Sorry, it's squared here, so you can say 43 squared times 47 squared, because so 2021 plus n can be 1 or 43 or 47. They are not possible because n is positive. You have 9 possible cases: 43 squared, 47 squared, 43 times 47, and 43 squared, 47, 43 times 47 squared, and 43 squared times 47. It has 9 positive divisors: 3 times 3, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the answer must be greater than 2021. 2021 is 43 times 47. You can cancel this. Also, you can cancel this. Now, between these numbers, you should check which number is... also, you can cancel this because n is positive. If it is this, n equals 0. In these numbers, you should find, because we want the smallest possible value of n, you should find a minimum one. 47 times 47, it's obvious that it is the smallest case. So n equals 47 squared minus 2021. If we calculate 40, we can factor from 47. 47 times 47 minus 43. It will be 4. It will be 4 times 7, 28. 2, 4 times 4, 16, plus 2, 18. So the answer equals minimum n equals 188. Singapore Mathematical Olympiad, SMO 2021 senior section, first round, problem number 25. Determine the number of 5-digit numbers with the following properties. All the digits are non-zero. The digits can be repeated. The difference between consecutive digits is exactly 1. So we draw 5 circles. And in many problems, when you want to count and consider, different cases, the most limited thing is better to consider. For example, here, we say, okay, this is x, you consider x is 1. If x is 1, then because we don't have 0, all the digits are not. So it is 2, 2. So for this one, you have 1, 3, 1, 3. So 2 cases, 2 squared. So you only need to consider one side. For 9 also, it will be what? For 9, so you say x1 and 9. It is similar, so times 2 is 8. For x, let's consider 2 and 8. If x is 2, the next one is what? 1. We consider only right side, left side is similar. 2, 1, or 3. After 3, you say, okay, it can be 2 or 4. And after 1, it is only 2. So 1, 2, 3, 3 squared times 2 because 8 also is similar. 3 squared because right side is 3, left side is also 3. So it will be 2 times 9, 18. Now let's consider when x equals 3. So if you consider 3, the next one is what? 2 or 4. And the next one is 1, 3, or this one, 3 or 5. So it will be 4 squared times 3 and 7 are same also. If you check 4, 5 and 6 are also same. 1, 2, 3, 4, 5. You multiply it by 5. It will be 16 times 5, which equals 80. So it is equal to 16 times 5, which equals 80. And if we add up all these numbers, 80 plus 18 is 98. 98 plus 8 is 106. So the answer equals 106.